All right, so my name is Miss Ivy. If this is the first time you look at me, hello. I'm so happy that you're joining this class. I hope you all had a good dinner. All right, so today we're going to do worksheet 23. All right, now some of you are from actually Saturday class. So I will finish up worksheet 23 before I go back to worksheet 22 for those students in the Saturday class. Because Saturday class, we didn't have enough time to do worksheet 22 last week. Right, because of content teaching, we took too much time for content teaching. All right, so without further ado, then let's start, okay, because it's 7:35 already. All right, so today is a very interesting topic. It's scientific endeavor. We are all going to learn how to be fantastic scientists. Actually, all of you are scientists. All right, let me just click here. Okay, first question. Okay, I'm waiting. There's a lag time. Okay, first question is, water freezes at 0 degrees Celsius and floats on water. We all know ice floats on water, right? Ice is always on top. I mean, that's how Titanic sank, right? Because Titanic actually hit an iceberg and the iceberg was floating on water. Now, this graph shows the change in density with temperature. So if you look at my laser pointer, so this is temperature. Now, when temperature is 0 degrees Celsius, 1 degree Celsius, 2 degrees Celsius, 3 degrees Celsius, 4 degrees Celsius, from 0 to 4, all right, from 0 to 4, what happens to density? Is density, can you tell me what happens to density? Increases or decreases? Can you all type into the chat? To help save time, I really need everyone to type in the chat as quickly as you can so that I don't need to waste time in waiting, all right? The reason why I want you to type in the chat is because if everybody speaks into the mic, then I can't hear clearly also. Too many voices together. Then I will know whose voice that is. So I really need to use a chat. Hey, look at the graph. All right. So from here is 0 degrees Celsius. This is 1, this is 2, this is 3, this is 4 degrees Celsius. So from 0 to 4, what happens to density? Is it going up or going down? All right. So that's where you all need to know how to use the word increase and decrease. Increase, I do not know whether you typo or you have the wrong understanding of increase and decrease. So very easy to remember. Decrease, start with D, it means down, going down. Okay, increase means going up. So it's quite easy to remember by, let me use my highlighter. Oh, start with letter D, and therefore down. So decrease means down, increase means up. Please don't get mixed up because don't lose precious marks. All right, then therefore the answer is increases. So from 0 degrees Celsius to 4 degrees Celsius, density actually go up. All right, increase. Density go up. Density is a little bit like weight, although it's not exactly the same. So density, think of it is lightweight. So in other words, it's getting heavier and heavier from 0 degrees to 4 degrees Celsius. But after 4 degrees Celsius, the trend changes from 4 degrees Celsius to 5 to 6 to 7 to 8 to 9 to 10 to 11 to 12, the density actually go down. Right, density gets less and less dense. It means lighter and lighter. So from 0 to 4 is getting heavier and heavier. From 4 degrees Celsius onwards is getting lighter and lighter. Of course, the word heavier and lighter are not the correct words to use. It should be getting denser and denser, and then getting less dense and less dense. All right, now which statements is correct? So over here says that water is the densest at 4 degrees Celsius. Densest is, think of it like heaviest, but you cannot write the word heaviest. It's almost the same meaning. You cannot write heaviest. Okay, so write densest. So it is true that water is the densest. Okay, because it's at the highest point. At 4 degrees Celsius, it's at the highest point. All right, so it's correct. Then here say least dense at 4 degrees Celsius. Of course, it's wrong because 1 and 2, one of them is correct, one of them is definitely wrong. Okay, then number 3, ice is denser than water at 4 degrees Celsius. Okay, so at 4 degrees Celsius, okay, so this is at 4 degrees Celsius. Ice is actually hang on, there's different interpretation. That's Now, if you look at 4 degrees Celsius, the water at 4 degrees Celsius, ice is actually less dense. If you look here, actually, I have a picture here. So what is happening is the reason why fish will not freeze to death is during winter time. If you look at the pointer here, during winter time, the top part is 0 degrees Celsius. That's where you have the ice. Ice is at 0, right? Okay, then this is 1 degree Celsius water. This is 2 degrees Celsius water. This is 3 degrees Celsius water. This is 4 degrees Celsius water. So all these are water except the top layer is ice, because ice will float on water. All right, so ice here, the rest all water. And then 4 degrees Celsius water is the densest. Densest is like heaviest. So heaviest go down, it will sink. So 4 degrees Celsius water is right at the bottom. All right. So if we look at this picture, all right, so this picture is the same as the graph. So here, 0 degrees Celsius water, and then 1 degree Celsius, 2 degrees Celsius, 3 degrees Celsius, then 4 degrees Celsius. So it will get denser and denser, it will get heavier and heavier as temperature goes up to 4. Then here, this number 3 statement say ice is denser than water at 4 degrees Celsius. At 4 degrees Celsius, you can actually see that ice is definitely on top. Water at 4 degrees Celsius is at the bottom, right? Okay, water at 4 degrees Celsius is the densest, is right at the bottom of the pond. Then ice is on top. Ice floats on water. So it should be ice is less dense than water at 4 degrees Celsius. So for statement 3 and 4, only 4 is correct. This is wrong. So actually the answer is C. All right. So I think the system, let me see, the system give you the right answer. Yeah, the answer is correct in the system. 1C, correct. Is everybody clear? Now, actually very interestingly, during summer, then at 4 degrees Celsius, let me put the laser pointer, 4 degrees Celsius water is always the densest, it's always the heaviest, 4 degrees Celsius water. Then 5 degrees Celsius water is less dense, lighter. Then 6 degrees Celsius, even lighter. 7 degrees Celsius, even lighter. 8 degrees Celsius, even lighter. As temperature goes up from 4 degrees Celsius onwards, the density actually gets less dense and less dense. That means as shown on the graph here, the density go down. After 4 degrees Celsius, when temperature goes up, density will come down. That is why this will be how the water will be during summertime. All right. So now we will watch, maybe because of time constraint, I leave you all to watch this video at your own time. All right, unless we have time later. This shows people digging a hole in the river, and it shows that on top is ice. All right, here on top is ice, and luckily there's still water at the bottom of the pond. If not, the poor fish will all be frozen and then be trapped in that layer of ice, right? And they will die. So luckily, fish will not die because at the bottom part, there is still water. 1 degree Celsius water, 2 degrees Celsius water, 3 degrees Celsius water, and finally 4 degrees Celsius water at the bottom. Then ice is on top. All right, then if I'm a fish, I will swim to the bottom because all right, so basically there's enough water here lah. It will, the whole pond will, the whole pond will not freeze and become ice. All right, let's move on. Okay, question 2. This graph shows a melting point of some substances. So now the question says temperature in the room is 25 degrees Celsius. So how many substances in the cat are liquids at room temperature? Okay, so for liquids at room temperature, just a minute, let me just turn off my, okay. Okay, let me double check when anyone is in the room. All right, so how many substances in the chart are liquids at room temperature? Now, if you look at olive oil, this is olive oil. All right, melting point of olive oil is close to 0 degrees Celsius. In other words, olive oil at 0 degrees Celsius, olive oil has melted already because they say melting point. So melting point means at what temperature the substance melt from solid to liquid. So please know what is melting. All right, melting is solid to liquid. All right, solid melts to become liquid. That is melt. Okay, so olive oil will melt at 0 degrees Celsius. Water will melt at 0 degrees Celsius. Then lard will melt at about, here is about 45 degrees Celsius. Butter will melt at about 50 degrees Celsius. Chocolate melts at about 50 degrees Celsius. Beeswax melts at about maybe 75 degrees Celsius. Sugar melts at 200 degrees Celsius. Wow, if you want to melt sugar, you need a very high temperature, 200 degrees Celsius. So now we are talking about room temperature. All right, room temperature is 25 degrees Celsius. So I look for 25 degrees Celsius in the graph. So this is 0, this is 50. So 25 is in the center. So you draw your dotted line. All right, then you will notice that olive oil and water, these two, they have already melted. All right, they already have melted because olive oil already melt at 0 degrees, haven't reached 25 degrees Celsius. At 0 degrees Celsius, olive oil has already melted into a liquid olive oil. All right, then water has already melted. Okay, now lard has not yet melted. If you want to melt lard, you need to increase the temperature. You need to heat up until the temperature is at 50 degrees Celsius. Then lard will melt. All right, so not so easy to melt lard. You need to increase the temperature to 50. And if you want to melt butter, you need to increase the temperature to 50 also. All right, so only olive and water has already melted into liquid. All right, so for question 2, the answer is B. And it is referring to olive oil and water. All right, because these two, their melting point is smaller, is a lower temperature than 25. Their melting point is a smaller number than 25. Right, is everybody clear? Any questions so far? Okay, if not, then we move on. Question 3, different amounts of force are used to stretch a spring. So this graph shows how force changes with extension. Now, extension means the increase in the length of the spring. How much you extend by, how much it becomes longer by, that is the extension. So what is the extension of the spring when the force of 2 Newton is exerted on the spring? So here they talk about 2 Newton. So look for 2 Newton here. All right, the force is 2 Newton. So it's over here. Then you touch the graph, you come down. It means 0.2 meter. So here says 0.2 meter. Now you want to convert to cm because all these are cm. So how to convert 0.2 meter to cm is 0.2 times 100 cm because 1 meter equals 100 cm. That will give you 20 cm. All right, so answer is C. Any questions so far? So this one is testing you 1 meter equal to 100 cm. By now you should know this. Right, if I'm going too fast, please let me know. Right, question 4 is talking about waste paper. We can recycle waste paper by adding the waste paper to the paper making process. All right, now when we recycle paper, we actually, the number of trees down will be reduced. All right, so when we count less trees, all right, it actually helps to reduce the amount of carbon dioxide in the atmosphere, in the air around us. So which one is the correct reason? All right, so why is it that when we cut down less trees, all right, then there'll be less carbon dioxide? So this is asking you why less trees in the end will have less carbon dioxide gas. Okay, anybody wants to try explain? Anyone want to unmute yourself? Why is it that less trees, therefore less carbon dioxide gas in the air?